Good morning. We have discussed galvanic cells, electrochemical cells, in that galvanic cells and Daniell cell. After Daniell cell, we have discussed the Nernst equation. Using Nernst equation, I have discussed how to determine the electropotential of calomel electrode and the uses construction working of different electrodes, calomel, glass, etc. and also the applications of these electrodes, isn't it? So we have a different type of cell, that is concentration cell. So you know what is galvanic cell, right? So what are concentration cells? So concentration cells are the cells where it's also a type of electrochemical cell, so where both anode and cathode are made up of same metal and are in contact with same electrolyte solution but of different concentrations. So here, due to difference in concentration, there will be flow of electrons from one electrode to other electrode. That is, we can observe flow of electrons from the electrolyte with lower concentration to the electrode with higher concentration electrode. So due to difference in concentration, electrons will flow from lower concentration electrolyte to higher concentration electrolyte. In our galvanic cell, we had two half cells, whereas both the electrodes used to made up of different metals dipped in their own salt solution. But in concentration cells, we have two half cells. Both the half cells are made up of same metal. That is the major difference. Both electrodes are made up of same metal dipped in their own salt solution but of different concentration. So the driving force here is difference in concentration. Due to difference in concentration, there will be flow of electrons from lower concentration electrolyte electrode to higher concentration electrolyte electrode. So let us see how the galvanic cell and concentration cell will differ. As you know, the galvanic cell is a type of electrochemical cell that uses spontaneous redox reactions to generate electrical energy. So concentration cell is also a type of galvanic cell with two half cells of different composition. Similar composition but of different concentrations. So electrodes used in galvanic cells will be made up of different substances, different electrodes. And the driving force in galvanic cell is difference in electrode potential. In concentration cells, both the electrodes are made up of same metal. The driving force is difference in concentration. Electrolyte. So electrolyte can be same. Okay, it is of different electrolytes or same salt solution. So here the electrolyte is of the same metal but of different concentration. So this is how the galvanic cell and concentration cell will differ. So now let us take an example of zinc concentration cell. So here both anode and cathode are made up of same metal. So zinc is dipped in zinc sulfate solution in anode, cathode zinc is dipped in zinc sulfate solution. But the concentration is differ. So one concentration is 0.1 molar, other zinc sulfate concentration is 1.0 molar. Both are connected with salt bridge and connected to a voltmeter. So the 0.1 molar zinc sulfate solution acts as anode and 1.0 molar zinc sulfate solution acts as cathode. So due to difference in concentration, we can observe flow of electrons from 1.1 molar, that is anode, to 1.0 molar zinc, that is cathode. So this flow of electrons can be observed until the concentrations of zinc in both anode and cathode are equal. Once the concentration of zinc in both anode and cathode are equal, we can no more observe the flow of electrons. So the electrode dipped in the lower concentration electrolyte acts as anode, and the electrode dipped in higher concentration electrolyte acts as cathode. Let us see the electrode reactions. At anode, Zn undergoes oxidation to give Zn2 plus and 2 electrons. At cathode, Zn2 plus will accept those 2 electrons to give Zn. So we can observe flow of electrons until the concentrations of C1 is not equal to C2. Once the concentration of C1 is equal to C2, there is no flow of electrons. These both reactions will not occur. Therefore, EMF will be equal. There is no net reaction because both will get cancelled. Net reaction is also 0. So the very important thing to be observed here is we can observe flow of electrons until C1 is not equal to C2. Once C1 is equal to C2, the flow of electrons will not be there. Therefore, EMF will be equal to 0. So how to determine the electrode potential? The electrode potential of concentration cell is determined by E cell equals 0.0591 by N log concentration of C2 by concentration of C1, where C2 is the cathodic species concentration and C1 is the anodic electrolyte concentration. C2 is cathodic electrolyte concentration and C1 is anodic electrolyte concentration. It is very clear where C2 is greater than C1. This is about concentration cells. So next we'll discuss about batteries. Thank you.